Okay guys, morning. So I should probably give you guys a context behind this talk. The day Naren asked me if I can present a talk, I was in a very heated argument with anonymous people on the internet. And this was like, they were, the argument usually as it would be Golang or what it is. So this is what we were specifically arguing about. So I'll give you guys. I've seen a lot of people make the same argument and same mistake when they go. Just like I was talking to Karthik some time ago, and you were explaining like a similar use case, and so I hope it will be useful to all of you. So like if you guys, I mean, how many of you did computer science at college? So if you remember your classes. Your teachers.
No, we don't remember.
No, I mean, if you remember some episodes from your classes, your teachers might have told you like algorithms and data structures are like the grammar and vocabulary of programming.
I still remember that Berus and Furusan. It's still there somewhere. That is the book I studied in college.
Oh, we didn't have it. We had C, CLRS. So, yeah. And so that's what they would have told you, right? And then I see a lot of people on HackerRank and places like Quora that people will be like, how do I learn more data structures? How do I learn more algorithms? But in real life, as you all know, we don't use that many data structures. We don't use complex data structures at all, like mostly. Dude, the keyboard isn't working. Okay. So my name is Mohan. I work for a company called Chennai, and I also manage a lot of meetups in the city, the Docker meetup. Some of you might have seen me already, I guess. So coming back to the topic, how do you use a data set in another language, let's say Java or C# or C++ for that matter? How do you use a data set?
Sort it, like that kind of thing.
What I mean is, let's say you have a use case and you want to use a data structure. What do? You go find, you go import a package and use type annotations, type parameters to give your type to it, and then you use it like STL in C++. Or you can do that in Go too. So if you go to this Git repository, he has like pretty much all the famous common data structures. So you can just take that, import that and use it. Yeah, so the end, right? But no, we have a problem. We can't do that in Golang because we don't have generics, right? So this is like one of the primary arguments that people bring up. So you can't have generic data structures in Go because you don't have generics. So if you don't have generics, that you can actually use that repository, but the problem is none of those things will be type safe, right? So if you actually put in the wrong type, you can't actually find it, and if the type doesn't have a method or something, it will break. So generics, I actually like the lack of generics because it actually makes you rethink the way you do object-oriented programming. Just like how inheritance lack of inheritance makes you rethink the way you arrange your objects and stuff, right? Like I was talking to Karthik some time ago. So in Java, what you would do, let's say there's some reusable component, you extract it out as an abstract object, and then you derive from it, right? You don't do that in Golang. What you do in Golang is you just extract that out as a component, and then you embed it inside, right? It's called object embedding, I guess, type embedding. So the lack of generics has some interesting effects, right? No generics means you don't have to deal with things like futures and promises, which becomes like if you guys remember things from like the IOJS thing that happened in the Node.js community, the whole IOJS thing happened because the Node.js maintainers were not allowing things like promises and these things to get into the node standard library. They weren't approving these changes. People are, you should probably check out this talk by Ryan Cantrell. He is the CTO of Ryan. One of his talks, he actually rants about this whole IOJS thing. I mean, he was totally against this whole promises thing. He wanted everybody to use even listeners and even developers. But people were like, we want promises, and they forked Node.js, introduced all these promises things. And then Node.js just came in, right? So that is that example. It was only possible to do this in JavaScript because JavaScript is untyped and you can do whatever you want in JavaScript, right? There will be a very open group that gets into the line and says this is the right way to do things, and then your productivity takes a hit. Like how many of you do JavaScript here? So do you actually feel your productivity has increased after this whole React thing, promises and all these things, or was it? I mean, how did you feel when Node.js and Express was the de facto thing? Like you were doing server-side things. Do you feel that your productivity then was great, or like now? Right? Now you have a lot more moving parts. You have flux and all these things. It's just unnecessarily complex things, and people just go with it because some local group is actually advocating that, right? And then there is this Python thing. I mean, if Naren were here, he would tell you about it. So Naren some time ago, he gave a talk on concurrency limiters in Python. It's like a total nightmare. They have everything. Like they have an event loop, they have a channel, they have like Yaka actor like thing. I don't know. They have everything, and that's like a single parallel. It's not like they have this, and you can choose. They have all the words mixed up, and they have only one concurrency pattern. But the best part of this is Python is not parallel anyway because of legit GIL. So people, when they come from a different programming language, they bring their old habits with them. Like Karthik was talking about me. I don't want to.
It's okay, fine. I like that.
Okay. So I was talking to him, and he was actually trying to port one code base to Golang. Meaning, a lot of people tend to do this, right? You already have an existing use case, and then you try to write it in Golang. But when you write it in Golang, or if you're new to Golang, you also bring in a lot of your design patterns and stuff like that from all your old programming languages. That's what happened in JavaScript, right? People who moved in from C#, they were the ones who wanted all the features that TypeScript now has. So people when they move from different communities, they kind of miss some features that they had in other programming languages, and that's why there's an actual Git project called Go Promises, which people don't use because it is not TypeScript. So Hendrik saved us that. So there is this whole fairy tale about reusability. So I mean, I'm sure you've all faced this thing. Let's say you have some functionality in component A, and you see yourself doing the same thing in component B. So what do? You extract this thing from both these parts, and then you make it a module C, which you can import in A and you can import in B. But just as your project grows, you need things that are specific to object A, and you have things that are specific to object B. And then there will be, so even though now you've extracted the C out, right? You've extracted C out, but you need optimizations that are specific to A, and you need optimizations that are specific to B. So you will have multiple cases inside C to handle edge cases, basically. So, and then there will be component A requiring a different version of module C, and component B requiring a different version of module C. This is like just at one level. There will be some dependency on A that requires a totally different version of module C, and then A will also require module C, and then you will have to deal with your own version of DLL, your little local DLL. And then there is this concept called Word's law, which says software is getting slower, faster than hardware is getting faster. I mean, we've all seen this happen, right? When we were kids, we had like machines that are 15 to 20 times lower than what we have now. But did our software get any faster? I mean, the way we do things, have they become any faster? Absolutely not. One of the main culprits behind, one of the main reasons this happens is because we tend to over-engineer things by using complex data structures just because complex and they are tools. And the problem with complex data structures is they perform poorly when n is small. And n is always small, almost always, unless you're like Google or Facebook, n is small. And when you're using generic data structures, right, the optimizations that you have are dependent on the type of data that you have. So if you're using generic data structures, you have no way of optimizing your machines because that's going to be optimized to the least common denominator, right? So there is this, how many of you watch Silicon Valley? Okay, so for those of you who don't know, Silicon Valley is a TV show from HBO. They have this, they discovered this new compression algorithm called middle compression. So there are Stanford studies that actually say that, that actually make it true, but it is mostly fictional, except for one type of data called time series data. You can have middle compression for time series data. But imagine if you had used some generic data structure, you wouldn't be able to, use this kind of algorithm on that data structure. Time series data. Right? You tend to lose all these kinds of advantages. So anyway, so you will have to make things less generic anyway. So what should you do now? So if you're a Mohan and you've heard me rant about like complex data structures and I'm telling you not to use them, so what should you do then? Write the structure yourself. Don't try to import it. This is like a general law pretty much for anything that you do in Golang. If you're like importing a third-party library, you're probably doing something wrong because you could have done that in a simpler way yourself, right? So for all you know, you would be using like just one function in an entire library, but you'll be importing like a library that is like 500,000 lines in it. That happens in Java. React.js. People use just one Ajax jQuery call and they'll be importing the whole jQuery with all its plugins.
So the advice is to do the opposite of JavaScript.
Exactly. And in JavaScript you will have like bazillion dependencies, and most of these dependencies.
Yeah, there are jokes about NPM restore.
There will be dependencies that are mostly like left pad and is13 and things like that. If you have to copy paste a few lines, it's okay because you'll be mostly doing it for only the second time. And if you see yourself doing it more than once, just use templates, but that's going to be very rare. And if you're copying stuff more than a few times, then there is some problem with your design. And maps and slices are mostly good enough because n is small usually. And then if your data structure is persistent, what you normally do is there are projects like Cockroach DB and stuff like that. What you would generally do is you would write it to a byte array and then you would save it in your persistent storage. And then when you print it back, you just unbox it back to your type, and you unbox it and cast it back to your type. So the point I'm driving home is go as productive because it's simple. Go pretty much removes the number of WTFs per hour that you experience when you write your code. In wanting features like generics, we are trying to take that simplicity away. And this is a Japanese word called kanzo, which means simplicity is elimination. And we have to embrace the constraints that we have. And it makes you, so when you embrace your constraints, it makes you think in different ways, and constraints generally make you a better designer. So that was my talk. Okay, questions?
Yeah, so I do. Right. So when we talked, right, I was telling you I was converting C sharp, inheritance heavy, generic heavy, trying to convert that to Golang. And I found that I had to know generics, one thing, right? So pro inheritance. So how to write it in Go?
You will
Multiple copies, no, I'll finish. So multiple copies of the same thing again and again. I found that ultimately I have more code that does the same thing only on different data sets. So I want to get at what is definitely the thinking in C sharp or the thinking in Java. General root thinking cannot be applied to code. So I want to pick your brain on what is the one thing is like this data structure, how to think about it. But this is not the entirety of how you think about writing code in Golang. I cannot think about writing code in Golang if I am thinking about how I want code in C sharp.
Yes.
What is that thinking that needs to be applied? How do I approach it? Because when I read Golang books, it tells me how to write stuff in the language. They don't tell me how to think in the language.
So one of the neat tricks I've found myself was you think in terms of machines. Let's say there's a car. In real life, you don't assemble a car from an abstract car class. Right? You assemble parts together. Right? And these parts are self-contained. So you call an engine an engine.
Correct. But so I get your analogy, right? But our entire educational structure is around this car and vehicle, examples that have been given. So when I try to write something, I cannot but think of it. This is why I don't like JavaScript, because I cannot actually think properly.
So the problem is there is no real thing called vehicle. It's going to be a lorry or it's going to be a car. You don't think in terms of abstract terms at all. So that way you can easily. So car has an engine, the lorry has an engine. If you have different engines, then you have different engines.
Different implementation.
Different implementation of the engine. But probably they have the same interface because they'll have to track the wheels, they'll have to track they'll be powered by the clutch and stuff, accelerator and stuff. So they'll have the same interface. But the implementation is going to be different. But the thing is, you stop thinking in terms of abstract things like vehicle or an animal or all these things, and then your normal you would just fall in place.
So what you are saying is I should not think in terms of what we have been taught in terms of software design patterns or software design.
These people are totally militantly against it.
No. I get it from the language itself.
Yeah.
I sort of have that. But so if I want to think about writing, like I said, there was payment processing, I have to think from scratch. How will I write this in Golang, and how I should try to resist thinking about classes and inheritance hierarchy.
You don't have to resist, right? Because even if you did think that way, you are not going to be able to write it in Golang.
Because that was the struggle I had. I spent a few hours on it, but the struggle I had was, okay, so how do I put this there? Then I found that, okay, I have to write one for each of these. It seems sort of like when you're using generics, right? You have a type and you have type annotations. So I sort of found that, okay, I have to, for each generic type now, I have to write one. And like you said, that is the way to do it, I believe, because each one is actually.
No. Usually, the function that you have would take in a specific, would take in parameters that have a specific interface. Right? Just like you can swap a car engine with a lorry engine because they have the same interface. So you generally, when you're writing functions, your parameters should be in the form of interface and the return value should be of structs.
I guess it's also the ability to unlearn. So, for example, when we moved from C to Java, the object-oriented model was new. It was something, I come from traditional C background. Okay. It was something, it took time for us to really appreciate the concept of an object and the use of those objects. I think Go is back
to that
model which.
I don't have a strong C background. I started with Java.
Yeah. I think, for me, having transition across both of those, it was a serious learning for me to appreciate the concept of object. It was powerful, right? And the reuse and so on. However, I think going back to non-object model
definitely. Like, so when my short trial to convert, what I learned is, so I am going to have to write more code to get the same thing done, but I will be getting better performance and closer to the middle.
You're right, but it also provides tools like interfaces to make it simpler. You don't need to write as many.
I didn't look into it that
But it's not really, I don't think it'll really give you better performance.
It is, and if you don't look at the details, right, it's a compiled language. It should give you better performance.
But he's already running in C sharp, yeah. So that way, right? Maybe if you are comparing it against Ruby or Python, it's going to be much more performant. But if you are comparing it against Java or C sharp, your performance gains are not going to be a game changer.
It may not be a game changer, but my guess is it's probably going to deliver better performance than Java.
yeah, definitely Java, much better than Java.
So if you write the same program in Java, it will not give you, if you use the same design in Java without all the baggage that comes with Java, bad design patterns, it will give you almost the same performance. But the thing is, Golang gives you a small binary which you can easily move around.
Yeah.
There is that convenience.
Yeah.
But other than that, performance-wise, it's not that big of a difference. It's mostly your way of thinking in Java that forces you to make complex things that makes the performance bad. If you take a Go program and translate it to Java, it will give you identical performance.
I think performance on empirical stuff can always test it out, right?
Instead of
Yeah.
And it's probably going to differ from application to application.
yeah, environment to environment also, right?
And also use case.
So in my case, like if there is no particular benefit in writing what a processing system might have in Go. Might be because I find the generics for me is a little bit more easier to maintain because there's less code to maintain, less problems you have. Then, right. So is there a use case for writing Go application specific or like domain specific, for example, finance domain? Or is it better suited for things like you're doing with crawlers?
Right now, since a lot of people are writing network-related applications in Golang, like distributed systems stuff, Golang, like more people are writing that kind of applications should be Golang. But Golang is generally it's a general purpose language, so it is suited for most things.
Suited for most things.
It's also said that Golang is built for concurrency in mind. Right? If you look at the hardware architecture, the processor architectures, the only way they are able to get better out of the processors is by adding cores. No more about frequency.
Yeah, hardware improvement is generally peaked more or less.
Peaked at a frequency because we are close to physical limits. But the way it is improved is by adding more cores into the same silicon. Right? So multiple threads is executing together. And that's where Go is supposed to excel, where you need concurrency. It's not meant for small ends, it's meant for big ends, where you really need to spread out and execute it back.
So when you talk about generics, specify like general functionality, and then when I compile, I'm going to like based on my usage, I am giving the specific type also. So it's like once it's compiled, it should give you the same performance.
No, generics is not getting performance by just existing modern C++. But there are other languages who runtime generics that have this problem, but that's not what I was saying. No, the thing is, if you get generics into the language, it gives people the ability to shoot themselves. And really local groups would do what they did to JavaScript. And your promises are really less performant than even less. But people just don't care about the performance loss because they think it's a better way to do things. Promises are actually slower than even this whole event thing that we had before this whole iOS. But people just say a lot got into option. Like, Karthik was saying sometime when he was talking, he was saying less code means less code to maintain means less code. That's not really true because less code also generally means that there are a lot of things that are implicit, which means you can't see it unless you dig into it. There are things that are getting passed without you explicitly saying so. So there are a lot of like that. You can write really one-liners in Ruby that will be like really cool when you write and just because it's one line. But when you are like when somebody else is reading your code, it will be a problem.
Yeah, Ruby is all about expressiveness and not explicitly about statement what you are actually trying to do.
Yeah, so that is the thing. It's like the Ruby's versus Golang thing. It's like totally the polar opposite, I would say. So did I answer your question? Oh, okay. So generics would let you bring all the bad habits from other languages. So that would make your design as complex as it was in other languages, which kind of kills the whole purpose of Golang. You wouldn't need Golang, right? You can just continue writing your own languages. You're going to like follow all the bad practices in your own languages. So that's why Golang is like, I mean, generics, the lack of generics is actually stopping that from happening. So that's a thing.
Have you ever used FFI?
Not the first time.
What functions?
I should do that in Python. So, alright guys, thank you.
Stop this.